Hello once again. Good morning everyone. My name is Chris Ramos and today I'm going to talk to you about plate tectonics. Say, when I say plate tectonics, what comes into your mind? Of course, plates. But when I say tectonics, what does it mean? We're about to find about it later. First, theory of plate tectonics. Earth's plates are in slow constant motion driven by convection currents in the mantle, and also plate tectonics is basis for viewing most geologic processes. Example are mountain building, paleontology, volcanism, and earthquakes. I mentioned the word paleontology. What does paleontology? To those who don't know what paleontology is. Paleontology is the study of ancient life, or what we also call prehistoric life. If you look at the map of the world, you may notice that some continents could fit together like pieces of puzzle. Here it is. It really does look like pieces of puzzle. Here's another picture. Plate tectonics, there are different kinds of plate tectonics, of plates. Some plates collide, pull apart, or scrape against each other. The plates that collide are called convergent. The plate that pull apart called divergent. And the plate that scrape against each other is also called transform. Each of those motions causes a different type of features when we're expressed. And also, the word tectonic refers to the changes in the crust because of plate interaction. Here is the world plates. Rigid lithosphere is divided into mobile tectonic plates. There are about 9 major plates and numerous smaller plates. What is rigid lithosphere? Rigid lithosphere is a rocky outer layer of the Earth. The major plates are located in African, Antarctic, Eurasian, Asian, Australian, North American, Pacific, and South America. The smaller plates is also located in Arabian, Caribbean, Caucasus, Juan de Fuca, Philippines, and Scotland. What are tectonic plates made of? Plates are made of rigid lithosphere. The lithosphere is also made up of the crust and the upper part of the mantle. Here is a picture of it. There are inner core, outer core, mantle, upper mantle, and crust. Next is the plate movement. Plates of lithosphere are moved around by the underlying hot mantle convection cells. Here it is. The mantle convection cells move around, and that is where the crust will have a different type of motion that will bring up the surface of the Earth. And those will be called some divergent, convergent, and anything else that it will be called. The modern satellites measurements reveal that plates move at rates of 1 to 15 centimeters per year. Isn't that amazing? The plates really moves every day, but only slowly. Here is the picture of it. And now the next is, what happens at tectonic plate boundaries? I'm sorry to tell you that would be the end of my discussion, and it will be continued by Parazoilo. That's all, thank you.
There are 3 types of plate boundaries: divergent, convergent, and transform. Divergent plate boundaries occur where huge tectonic plates move away from one another. This occurs above rising convection currents. The rising magma pushes up on the bottom of the lithosphere and flows laterally beneath it. This lateral flow causes the plates to move in the directions of the flow. At the plate boundary, the 2 plates move in opposite directions. Divergent boundaries are constructive boundaries because new crust is formed. As the plates move apart, molten magma fills in the gap and creates new crust. There are 2 major types of divergent boundaries: continental and continental lithosphere, and oceanic lithosphere. Oceanic and oceanic divergent boundaries occur where 2 oceanic plates move away from one another. This is where seafloor spreading takes place. The most common example is the mid-ocean ridge, which stretches around the world. Divergent boundaries are constructive boundaries because the rising magma creates new oceanic crust and lithosphere. The mid-oceanic ridge runs right through Iceland. Continental and continental divergent occur when two plates of continental lithosphere move away from one another. As the magma rises, new lithosphere is created. The East African Rift Valley was created when continental and continental divergent boundaries moved away from each other. The Red Sea is another example. The Red Sea was formed by the divergence between the African plate and the Arabian plate. The rift transitioned eventually from a continental and continental to a continental and oceanic plate boundary.
The Himalayas are a prime example of how tectonic plate motion can manipulate the Earth in extraordinary ways. The Himalayas are highest mountain range on the planet, formed by the collision of two tectonic plates that were carried by the Earth's lithosphere. Continent-oceanic crust collision creates subduction zone. Ang subduction zone ay ang lugar kung saan nagsama-sama ang dalawang lithospheric plate. Ang isa ay sumasakay sa isa. Karamihan sa mga bulkan sa lupa ay nangyayari parallel sa at sa loob ng bansa, mula sa hangganan sa pagitan ng dalawang plate, isang lugar na kilala bilang Volcanoes at Nera Fault Zone. Oceanic plates subduct underneath the continental plate. Oceanic plate heats and melt. The melt rises forming volcanoes. Example is the Andes Mountain. When the ocean plates crashes into a continental plate. The subducting slab dehydrates, inducing partial melting the overlaying mantle wedge. The mantle wedge feeds magma into the continental crust, forming volcanoes. So, naamay continental crust and oceanic crust. So, ang subducing slab is siya ang nag-inducing partial melting sa overlaying mantle wedge. So, ang oceanic crust ang karaniwang binubuo ng madilim na kulay na mga bato na tinatawag na basalt at gabbro. Ito ay mas manipis, mas siksik kaysa sa continental crust. Nagawa sa mapusyaw na kulay ng mga bato na tinatawag na andesite at granite. Ang mababang densidad ng crust ng continental ay nagiging sanhi ng lutang or float nito ng mataas sa ibabaw ng malapot na mantle na bumubuo ng tuyong lupa. An excellent example of oceanic continental convergence occurs in the west coast of South America. So, ang Nazca Plate, which is the oceanic, ay subducting sa ilalim ng South America Plate, continental. Ang South America Plate ay continental. Ang chill trends ay ang surface expression ng subduction. So, ang Nazca Plate is subducting sa ilalim ng America Plate, which the continental. Ang continental is sa taas, and the Nazca is subducting sa ilalim ng South America Plate. And the chill trend ang surface na expression ng subduction. Oceanic plate collision. Kapag nagbanggaan ang dalawa, ang isa ay tumatakbo sa ibabaw ng isa na nagiging sanhi ng paglubog nito sa mantle na bumubuo ng isang subduction zone. Ang subducting plate ay nakayuko pababa upang bumuo ng isang napakalalim na depresyon sa sahig na karagatan na tinatawag na isang trench. The world's deepest parts of the ocean are found along trenches. Example of this is the Mariana Trench is 11 km deep. Ang transform boundaries. Ang transform boundaries is lateral slipping plate movement where plates slide past each other. Ganyan. Past each other. Ang example nito is ang San Andreas Fault. Ang transform plate boundary kung saan ang isang manipis na hiwa ng kanlurang California bilang bahagi ng Pacific Plate ay dumudulas hilaga kanluran kalampas na natitirang bahagi ng North America.